Hello, I'm Nathan.
And I'm Erika.
And in this video we will be introducing you to the phenomenon known as soil salinization in an agricultural context. Soil salinization has a detrimental effect on an estimated 10% of all land used for food and fiber crop production. With the global population growing, salinization works to counteract technological innovations in agriculture, effectively stagnating the food supply.
It therefore stands to reason that soil salinity is an issue that should be addressed if we wish to continue feeding our people in the centuries to come. By the end of this video, you should know the answers to the following 3 questions. 1. How does salinity and sodicity affect agricultural production? 2. Why are irrigated soils extremely susceptible to soil salinization? 3. What are the 2 methods for monitoring soil salinization? What are the drawbacks and limitations of these methods?
First off, Erika will explain what soil salinity is. Then I will discuss the current techniques for monitoring soil salinity. Monitoring soil in salinization-prone regions is necessary for preventing salinization, but the prevention methods will not be discussed here, as they are extremely situation-specific.
Soil salinization is a process where salts build up in the soil. The ions in these salts include sodium, calcium, magnesium, potassium, chloride, sulfate, carbonate, bicarbonate, and nitrate. Speaking in agricultural terms, high salinity in soil is a problem. First, salt cations make it difficult for plants to bring in the water and nutrients that they need to grow, so salinity effectively stunts the growth of crops. Secondly, high concentrations of sodium and chloride ions become toxic to plants. Thirdly, high sodicity, or in other words, high sodium concentration in soils cause soil dispersion, leading the soil more susceptible to erosion. This happens because the sodium cation absorbs clay particles in the soil, causing them to disperse. Salinization is especially common in irrigated farmland, particularly in arid regions. Irrigation inputs cause the water table to rise so that the plants can uptake water. This rise in water table brings salts from the deeper soil layers and bedrock up to the soil surface. The water then evapotranspirates from the soil, leaving the salts behind. In arid regions, there is inadequate precipitation to flush the salts out of the topsoil, and so they accumulate and produce conditions not suitable for efficient crop production. Salinization is also common in coastal regions where salt water from the sea or ocean could find its way into the groundwater.
In order to create solutions for soil salinization, one first has to know the extent that the problem prevails. Salinization is both a spatially and temporally discrete phenomenon with many input variables such as soil type, soil texture, topography, climate, and land use practices. Thus, in areas subject to salinization, soil monitoring is currently the way to go, versus an extremely complicated and possibly not completely quantified empirical approach. One way, and perhaps the most common way, is to take numerous soil samples from the field in question to measure the salinity. Salinity is quantified by measuring the soil's saturated electrical conductivity, where the salinity and electrical conductivity are correlated positively. Monitoring by this method is quite costly to do often and consistently, thus there is room for innovation. Another method for monitoring the salinity of soil is by using remote sensing spectral imagery. When salts build up in the soil, there is often a buildup of salt crusts on the surface. The electromagnetic signature of a field with these crusts is distinct enough to distinguish between salinized and non-salinized soil. According to one study, there was a promising correlation between their remote sensing results and the soil sample results. The large pixels on the spectral images make it impossible to find fine-scale variations in salinity, and the method is both extremely complicated and is limited by the availability of spectral imaging technology. In my opinion, the future of salinization monitoring involves semi-regular sampling with empirical prediction, using prediction methods that have possibly not been derived or tested yet.
Hopefully now you know a little bit about soil salinization. All the sources of our information are the next few slides if you would like to read the individual studies or look at the pretty pictures. Thank you for watching and have a great day.